Right, I'm going to get started, and I'm going to be talking to you today about Spock, which is a testing DSL or language based on Groovy, and I'm hoping to show you that it's applicable beyond the bounds of just testing Groovy applications. So here's the slide, and that's it for slides. We're going to take a look at some code. So what I have is a really simple Java application. It's a simulation of a vending machine, the kind of thing you might do as a programming exercise in university or early on in Programming 101. And I've got a bunch of JUnit tests for that, and what I'm going to do is show you how to implement the equivalent tests in Spock. Really quick whistle-stop tour of the app. There's a vending machine class that does the kind of business logic, as it were. It has a hardware device which simulates the kind of hardware functions of a vending machine, and we've got a couple of enums, a coin with different denominations, and a product as well, which we'll get to just now. But you don't need to worry too much about the app. You also don't need to worry too much about Groovy. I'm very used to it, but you can write Spock tests in a very Java-like syntax, or you can use the really advanced features of Groovy. Doesn't really matter. A lot of the stuff you can do with Groovy is equally applicable to writing tests in JUnit. Right, so let's jump in. So the first test I've got here is asserting that before I've inserted any coins into a vending machine, it tells me the amount of credit is 0. So we're looking at standard ham-crest matching, that kind of thing. So let's do the same thing in Spock. So this is maybe one of the first interesting features about Spock, that you can have these string method definitions. You can't do that in normal Groovy, I don't believe. That's a thing that's special to Spock. It looks really nice in reports as opposed to the standard camel case. And I'm doing something really simple here, so I'm just going to say expect. I need to create my class under test. Let's run that. In the interest of not taking all day, I'm not going to show you every single test failing, but yes, you're absolutely right. Thank you. Never do live coding. I'm not going to show you every single test failing, but I strongly believe in the mantra of never trust a test that you've never seen fail. So there we go. You'll note there's no assert keyword because Spock works on this notion of blocks. So I've defined an expect block there, and I'm saying anything that occurs in that block is an assertion, unless it's assigning a variable. We'll get to that. But anything that can be evaluated to a Boolean or a Boolean-like expression is treated as an assertion. So if I change that to 1, rerun the test, and it fails, and we also get this really nice diagnostic output. One of the things that Groovy actually imported from the Spock library a couple of releases ago was this power assert diagnostic, where it completely breaks down a failing assertion. And you get this now in the standard assert keyword usage in Groovy, but it came originally from Spock. And it will show you the value of every part of that expression. I'll show you some more complex examples later, and you can see it decomposing both sides of the Boolean expression and showing you exactly what's failing. And this is really great because diagnostics are enormously important for maintainable tests. And in Java, you can spend quite a lot of time writing ham-crest matches and that kind of thing that give you good diagnostics. Here, you really just get it right out of the box. It's very powerful. So let's look at... So that's an expect block, which is simply a bunch of assertions. So let's move on to the kind of BDD style you might be more familiar with, the prepare, act, assert style, which in Spock is given, when, then. So we're now going to assert that when we put some coins in the machine, we get some credit. I'm not going to type out every single method name as we go along, but in this first test it's quite useful to show you how it's done. So when I insert a coin, then so that's exactly equivalent to that JUnit test you can see on the left-hand side there. I'm trying to squeeze things in on this monitor and keep it legible as well. The fact that we're just using the value keyword, value as though it was a field there, that's a Groovy thing. Anything that's got get on it, you can treat like that. If you're not familiar with Groovy, that's what's going on there. It means exactly the same thing as get value. So let's run our test again. Oh yes, I need to fix that first one. So what we've got there is a when and a then block. So when is kind of the action that your test is investigating, the behavior that it's investigating, and then is similar to an expect block is a bunch of assertions. An expect is almost like, you can consider it like a when and a then block combined. So these blocks, if you know historical Java, and I don't think anyone really uses this feature in Java, but those are actually go-to labels from Java, but Spock treats them in a special way, and they actually have semantic meaning in Spock. So anything that's in an expect or a then is treated as an assertion. There's kind of one bit missing from the BDD given when then, so I'll show you how that works. So you can say given for preconditions. Given I've already inserted a coin, when I insert another one, simple enough. All passing, great. So there I've just used a when and a then. Here I've used an expect. You can mix this up a little bit. You can have given and an expect, or when and then, if that's appropriate. It's really just down to the semantics of what you're trying to test and what makes most sense in your scenario, but either one can be used. You can use a given without a when and then, just have an expect instead. Whatever makes most sense. So that's the real basics. Everything is working around these blocks. The when is the action, then or expect is assertions, given is preconditions. Any of them can be augmented with an and block, as many and blocks as you like. So you can add extra actions, extra assertions, if that makes sense, to divide them up. They can also have labels, so I can say, given I have already inserted some money. And the really nice thing is that isn't just a comment, it's retained in the bytecode, and some of the new reporting tools that are coming along in the next Spock release, I think, are actually going to be outputting that kind of thing, and you can use it for generating documentation if you want to do that kind of thing. It's not, it's not discarded at compile time, it's present in the bytecode. There's lifecycle methods as well, similar to the at before class, and so on from JUnit. I'll get to those in a further example. So let's move on to maybe like one of Spock's real killer features, which is parameterization. This is one of the most horrible things to do in JUnit, I find. Let's look at an example of how one might approach this in JUnit, which is to use the parameterized runner. And there you've got a test that is using these values fed from this parameters method into some kind of data object there. So I find this syntax extremely confusing, but it has to return a collection, and inside that it has to have an array, I believe. And for some reason we have a three-dimensional array here that then gets converted into a list with this packaging function. Okay, the data setup's kind of confusing. The assertions are right. If I run it, we've got three different data sets there. We do get three different sets of results. They don't have any different descriptions. So if I kind of screw up one of the ways one of those runs, it's not necessarily the most obvious thing which one of them is actually wrong. Another approach is the theory class. It's also worth noting with this that those set of parameters apply to every test method you have in here. I think in newer versions of JUnit now you can give them a name or something and tell a test which named set of parameters to use. I haven't really experimented with that. So another approach is theories, which have a slightly simpler setup method, multi-dimensional array. It's a little bit more readable, I find. And instead of injecting into a field of the test class, you have a parameterized test method. So here, I'm just testing as I stick a bunch of coins in the machine. I get accumulated credit. Let's run that. And the really disappointing thing with theories is you don't get separate output for each test. So if I break that in the same way I break the previous one, the entire thing fails. I don't know which of those, actually only one of those iterations failed, but I might as well just use a for loop and not bother with this fancy syntax. So let's take a look at how we do this in Spock. Let's implement exactly the same test. So when I'll be polite and put some curlies around that. I'll use a Groovy closure here to sum up those values. All that's doing is summing up the values of whatever coins I introduce. So now I've kind of got a missing parameter here, and the way we deal with that in Spock is to have a where block. So I can say coins, a funky left shift operator, and run that. What that's doing is exactly equivalent to the theory there. We're going to have three iterations of this test. The first one will receive a list with one item in it. The second will receive a list with another item in it. And the third will receive a list with two items in it. The square brackets there is Groovy's literal list syntax, if you're not familiar with it. Okay, that's worked fine. Like the theory, we've only got one result there in the test. Let's do something about that. So we can add an annotation to this method called unroll. And look at this. Autocompletion in IntelliJ in the unroll statement. If I run now, sorry, the font's so small in this test pane at the bottom, but you can see we've got three different test outputs. And the test description has been changed to the kind of evaluated expression from that unroll, which is kind of nice. So you can see the names of the coins in there. So if we break one of those in the same way that I broke those other tests, you can see exactly which one I've messed up, which one's failing. You can see from the report title which data set has caused the failing test. So that's a big advantage straight away. We can also do something really cool here now in recent versions of Spock. We can put the where expression right into the method name there with exactly the same result. Unfortunately, I think the autocompletion doesn't work there yet. I'm sure that will come. And we can also then move the unroll up to class level. Yeah. And that will unroll every single test in the class. Because the really nice thing about Spock parameterized tests is that data set is per method. You can have a different where block for every single test method in the class. You can have some tests that don't have where blocks, some that do. When you're using this is called a Datapipe syntax, where you're using this left shift operator to inject a bunch of different things. That can be anything iterable. So you can have tests that use methods to feed data. And now I've written one in the past where it goes and reads database metadata and gets every table from the database and checks that it has a primary key. So the really nice thing there is if you add a new table, the test starts checking it straight away without you having to change anything in the test itself to accommodate that. So that's the kind of original syntax of... oh yes, I wanted to do something else nice, which is to show you can have multiple values here. And you can, when you're using an equals here, instead of a data pipe, you can refer to the variables created in the equals. So if we say, we can extract this output here, and you can see there you get autocompletion and IntelliJ on things that are in the where block, which is really great. So that's really nice and clear now, because our test is kind of completely divorced from inputs and outputs, which are bundled up into the where block. Run that to prove I'm not lying to you, and yes, it works. You can have multiple data pipes there if you really feel like you need to, but there's a better syntax for doing that, which I'm going to show you now, if you've got kind of multiple repeating values. So because it's really easy in Spock to have multiple sets of parameterized tests within the same class, which is not very easy with parameterized tests in JUnit or theories in JUnit. I'm going to show you the other syntax right in this same class, if I can remember what I'm supposed to be doing here. So what we're going to say is, given I've inserted some coins, much the same as we did before. Expect oh yes, when I buy something, then the remaining credit is equal to let's do it this way first. Come on, Auto. So we're going to say the amount of money left in the machine after I've bought something is the amount I inserted minus whatever that thing cost. So let's look at the cool data. Let me get this out of the way. That's not what I wanted to do. Awesome. So we've got two parameters going into this. We've got the coins as before, and we've got a product. Or products, potentially. In fact, let's do that, yes. So we can have another array. And this is the data table syntax, which is slightly more recent than... So for our first iteration, we're going to insert 4 quarters and by something, second iteration, we're going to insert something else, a couple of things in fact. That looks a bit messy, doesn't it? So let's auto-format that. IntelliJ understands Spock data tables, so it lines everything up nicely for us when you auto-format the code. So instead of using this Datapipe syntax here, we've got two columns, and that's defining the parameters that are going into that test. Ah, fantastic. Yes, you're absolutely right. Thank you. Thanks. Always a couple of glitches. Nice to keep people paying. Thanks. Thank you. I'm doing this deliberately just to make sure you're paying attention, right? Now I've got a null pointer. Awesome. Ah, yes. I can show you a setup method now. This is because I've started actually buying things out of the machine. It's going to interact with that hardware thing that I showed you before, so I'm just going to set that up quickly. We will come back to Stubbs and Jmocks in a minute. Hey, it works. We can parameterize that as before. So this syntax is really great when you've got kind of multiple sets of parameters that belong together. You can also mix in the syntax I've got here where I'm kind of assigning an input. I can mix that in. So I can say, let's say amount inserted. And again, you can refer to these variables greater than the columns as exactly as before. Perfect. So I hope that's kind of convincing that parameterized tests are way, way simpler in Spock than in JUnit. And you've got various different methods for doing it for different cases. I also find that you don't necessarily have to use the where block for iteration. It's really nice also just for separating out inputs and outputs of tests from the logic of the behavioral expectations. So you can simply have a lot of things that use the equals operator, and it just gives a nice structure to your test that you've got these parameters instead of scattering values throughout the test logic itself. It's really good for the clarity of the test. Okay, let's move on. I'll just have a sip of water. You saw me set up a stub there. So Spock has its own mocking and stubbing framework built in. And I'm going to show you how that works next. So in IntelliJ here, in JUnit here, I'm using Jmock, which is one of the most popular mocking libraries. I've got a test here that says, what am I doing? I'm inserting some coins, and I'm pressing the button to return my coins without buying anything, and then I'm expecting that the hardware device returns me a coin of the type that I inserted. Yeah, Jmock's interesting, I find, because I don't, to this day, understand what that double bracket syntax is all about there, but that's what you have to do. And one of the things I don't really like about this is that you put the assertion about what the mock is going to do before the action rather than after it. Let's take a look at Spock's approach. So let's implement the exact same test here. So I've got the vending machine set up here, and this is the thing I want to mock, so I'm going to just say mock. You saw me use stub earlier. That's mock is a kind of variation on the same thing. And what I can say now is, what's this test expecting here? That I should get one in invocation of the return coin with this penny parameter. So this is what that looks like in Spock. Lovely. It looks a little odd at first, but once you get used to it, I think the syntax is fantastic. So I'm saying that I expect one times this action on the mock. You can have as many lines here as you want. Let's run that, and I can show you it working. Let's change the expectation to be incorrect. And you can see the diagnostics that comes out when you get a bad expectation or an expectation failure. So it's saying it expected one of these actions with this parameter, and it actually got this. So you get some pretty good diagnostics, much like the power assert that I showed you earlier. That didn't used to be the case. I think that only came along with the last release of Spock, and before you were kind of a little bit in the dark about what had gone wrong with your mocks, but now it's much, much better. Yeah. So one of the interesting things is that mocks, unlike Jmock in Spock, they're lenient. So if you don't make any assertions, it will still allow things to happen. Whereas in Jmock, you have to specify everything that you want to allow, or you can stub things using the allowing method. So let's go in and screw this up on the wrong one. Get off. And I'll deliberately break this. Where is it? Let's just put another. It's stupidly going to return an extra coin for no reason. I didn't put the test back correct before, sorry. Oh dear, our test still passes. So how do we do a stricter thing there, where we can simply say, I want 0 further invocations of that method with, I think that was the command we used. Good, now it breaks, because that did in fact happen. However, it's a bit stupid to tie it to that parameter, so Spock has you'll notice everything is extending Spock lang specification here, and it has a protected property underscore, which is a wildcard for using mocking. So that means the test will fail if I return any kind of coin beyond that one I expected. Bingo, still fails. But, we really shouldn't be doing anything else with this, right? So we can use the underscore there as well to say that you mustn't interact with any other method. Or actually, we can omit the parameters. Don't do anything else with that object. Or, even further, Don't do anything else with any other mock. Still reporting to us nicely what's wrong. Or we can go even further and say, yeah, don't do anything else with any method on any mock. Great. So we've got lots of options for wildcarding stuff there. We can also do cool things like using a regular expression here. I think that's how you do it. Bear with me if it isn't. Apparently not, but there is a syntax for doing regular expressions for the method names and so on. We can use a closure to match particular parameters and so on. I'm not going to go into too much detail there, but you get the idea. There's an enormous amount of flexibility of what you can do with the expectations in the mocks there. But I think for our purposes that works pretty well. Let's fix our class. Let's make sure it still fails actually, and then fix our class. Yep. I'll take my stupid line out. And now it passes, perfect. So, in a similar vein, you can just start with, if I've never inserted any coins, so the JUnit test is using Jmock's never method there to say never insert, never return anything if nothing's been inserted. Exactly the same as what you've just seen. So what about Stubbs? I talked about the fact that mocks are lenient by default in Spock, unlike Jmock. So here's Jmock using its allowing method to say that, what's this test all about? Oh yeah, it's just checking that when you return coins, your credit goes down, obviously. Otherwise, you'll be able to buy things for free. So it's allowing any amount of return coins to happen and then asserting that the credit is equal to 0 at the end. So let's do that in Spock language. So the precondition is I've inserted some money. When I ask for my coins back, then I've got 0 credit left afterwards. Awesome. Didn't have to do anything with even though it's actually calling a method on that hardware object, I didn't have to set anything up, because by default, this happens to be a void method, so that's fine. If you have a method on a mock that returns a value, Spock will return a kind of groovy false value. So if it's Boolean, it'll return false. If it's integer, it'll return 0. Object of some kind, it'll return null, and so on. If you really do want to set up what you want it to do, you can simply have a kind of an equivalent of an allowing before the when block. So it's important to note, I should probably mention, that the way these mock assertions work is that they assert based on what happens in the when block. So if you're interacting with mocks in the given for some reason, which I don't really see why you would be, it doesn't work the same way. That the assertion is about what goes on in the when block. Because again, Spock is assigning meaning to those labels as opposed to just using them as labels. So here, for stubbing, we can set things up before the when block. If this wasn't void and I wanted to return a value, I can do something along those lines to return values. You can return iterables and so on. I think you can use a triple right arrow to have a kind of sequential set of return values that it will go through. And there's one other nice thing you can do with Spock. Let's get this out of the way a second. So we've got another test here that is inserting a bunch of different coins, and then so what it's doing is it's where are we? It's inserting 17 pennies, and then hitting the return coin button, and it kind of gives you back more efficient change based on what's in the machine. So that's exactly the kind of algorithm you might be expected to do in university or something. So let's say we've put a bunch of coins into the machine previously, and somebody's come along and inserted some money. Right, so we should get 1, and for the sake of strictness, nothing else. Really? That's irrelevant to what I was trying to show you, so let's take it out for a minute. I'm not quite sure what the problem is. So yeah, our test there worked, multiple assertions, but it would be kind of nice if we could group those in some way because they're all using the same mock object, so we can do that now with recent versions of Spock. Yeah, works just the same. Which is quite a nice syntax for grouping lots of interactions with the same mock. We can also use, instead of just a simple integer here, we can use ranges, we can use wildcards, so I can say, it would be incorrect in this case, but I can say, I expect this to happen any number of times. Or I expect one or more calls to that. Here I expect 2 or more, or something along those lines. You get the idea. You can use all kinds of wildcarding and ranges there to assert how many times things get invoked. 10 minutes left, so I'm going to skip these next couple of tests, which are really just showing you more stuff you've already seen, and move on to the next. Move on to some of the next stuff. So I talked about Stubbs earlier. It's really just the same thing as a mock, except you don't make assertions about it. Spock has also introduced something called a spy, which is kind of an evil but occasionally useful feature where you can wrap a spy around a real object that's a collaborator of your class under test, and then it will behave exactly as it normally would, but you can also verify that things get interacted with, but it will carry on and call the underlying implementation. So it's pretty horrible. It's kind of a code smell, but it can be pretty powerful when you're testing legacy code, particularly that wasn't really designed with testing in mind. Sometimes it can be useful. And they can also act as partial mocks, which are another kind of code smell, but have their uses occasionally. So you can have an object where some of the methods are the real ones and some of them you want to mock out using a spy. Spock's mocks can't mock anything static at the moment, I don't think. I think there's an extended mock type that can do that kind of thing, or if you really need to, you can use Groovy's metaclass capabilities to do that. Let's take a look at another killer feature, though, that I always think is quite fun because it looks like magic when you come from a Java background. So here we've got a test that's saying the machine dispenses products and deducts the price from the credit. So we are making mock assertions, we are inserting a bunch of coins, buying something from the machine, and then we're saying, okay, I was given my item that I purchased, and the machine now has less credit in it than it started with based on whatever it was I just bought. Fairly similar to the kind of thing we've done already. Let's take a look at how we might do that. Oh, that's a nice auto-completion feature there. Thanks, IntelliJ. I haven't set up my class under test, that's why the thing's not working properly. Right, so we've said there, we've inserted 4 quarters, we've bought something, the machine has given that to us, and now so it should be what? Quarter dot value times 4 minus the price of what we bought. Yeah, it's not very pretty, is it really? It's very dependent on what we did before, so it works though. That's nice. But we don't know, we don't really want to care about how many coins you put into it, how much change over the value you want, so let's just say this. The credit should now be whatever it was before, minus the price of the thing we bought. Fantastic. Let's get that wrong and show you it failing so you can see that it really is doing what I'm telling you it's doing. Yep. Come on, scroll. Yep. Missing value. Okay. Let's just take that off altogether. I'm not quite sure what I've screwed up there, but something apparently. So there you go. There's some nice assertion output. The old value was 100, and now it's 25, which is correct, but I've made the test wrong. So the way that's working is that this old method returns you the value of whatever that expression would have evaluated to before the when block happened. And you can use that for absolutely anything. I've used it with Selenium tests to test that columns are getting added to or rows are getting added to tables, or values are updating in web pages. You can use it like this. It's really useful where you don't really want to make any assumptions about what the value was previously, just that it has now changed. So I used it with some caching stuff where somebody moving around a website was causing things to get put into a cache. Then they do something specific, which is what I'm testing, and there should be one more item in the cache now, or there should be no further items in the cache, depending. And it's great there because the value previously is kind of unpredictable. So it's really useful to not have to worry about it, not have your test breaking, because suddenly your setup step there changes in a slightly irrelevant way in terms of what you're actually trying to assert. So this is one of my favorite Spock features, and I use it all the time. And as I say, it kind of looks like voodoo if you come from a Java background, but what is really going on here is it's kind of obvious if you use a debugger on it, because you'll find that if you follow this through with a debugger, it'll execute the given step, then it'll jump down and do the old block, then it'll do the when, then, and everything else. So it literally just reads it beforehand. Obviously, you could do the same thing by putting a variable up further up the test, but I think this is a really powerfully readable way of doing it. A couple of minutes left, so something very, very quick. Look at exceptions in mocks. So let's say I try and buy something and I haven't put enough money in. In Jmock here, what we're saying is that allowing a call to dispense, that will throw an exception saying out of stock. Sorry, it's out of stock, not that I haven't put enough money in. Similar idea though. And that the credit remains the same afterwards. So we can use old again for that. So there we're going to say that I do expect it to be, I should put this one right, sorry. I do expect that value not to have changed, because I don't want the machine to steal my money if it happens to be out of stock or something. But how do I do the exception throwing? Don't care what it is. We use a closure, and we can just put an action in there. Perfect. The Jmock one there is using allowing though, so we really shouldn't be making an assertion, I guess. So I'll just set that up beforehand as a precondition, like that. Same thing. So these closures that you can use to kind of implement actions on mocks can take parameters which are mapped to the parameters that are actually get passed. So if you need to do something crazy with the parameters, you can do. Most often they're used for exception throwing like this. But that you can do some other tricks with them. 1 minute left. Awesome. Let's try and squeeze this one last test in, which is asserting that an exception gets thrown. Simple as that. So How's that done in... oh, you do it with a try-catch in JUnit. Spock has a syntax for it, so you can just say in the then block, I expect an exception of this type to be thrown. Perfect. I can also capture that exception object if I need to. And then I could use that to make further assertions about messages and that kind of thing. I'm out of time, so maybe grab me for questions afterwards, or... Sure. So, hope you guys found that useful. That's Spock. Very, very quickly, all the code I've been showing you is on that URL there, and the second URL is the Spock website itself with all the documentation. So, hope that was useful, and grab me for questions afterwards if you have any. Thank you.